Hello everyone and welcome to the new episode of CPP Next. In this episode we will discuss a feature of the standard that helps us with creation and maintenance of shared pointers from an object. And it also showcases the usage of CRTP, exactly what we talked about in the previous episodes. Moreover, this feature will make us safe and I will show you how exactly it will make your code safer and better. I wanted to create this episode because a person from my company started asking questions of how exactly he should use shared pointers and why is this feature so important and how it works. So I thought it's going to be a great episode for everyone because we already spoke about CRTP and this is something that is a continuation of the series. As always everyone, please like and subscribe. Let's jump in by writing a simple test function. So we see this function is really simple. It received a type under test. This type under test has to have a function called create. This function is a static function that creates the first shared pointer. And then we have a member function that returns a shared pointer. Now let's create our first class that contains both of these functions. What do you think will happen if we will run test function on bed? Let's see. Whoever said that we will have a segmentation fault or a double free was right. But why did it happen? Let's try to understand. To understand what happened, we have to remind ourselves how shared pointer look internally. If you remember correctly, the shared pointer has a management sector and a data sector. The data sector is allocated if you're using make shared, or it is just brought as a pointer if it's needed, if it's something that is external from the shared pointer creation. The most important part here is the atomic counter. In the management area, we have atomic counter that counts how many instances we are looking at the current time. Now, to understand what's going on, we will play the debugger. We will look at each line of the code and try to understand what it will do. Line number 1 creates a bed pointer from make shared. That means we are allocating a full pointer with a management area with an atomic counter, and we have allocated the data here. When we are looking at y equals x get shared, we are creating a new shared pointer with its own management area and a data area. The data areas are exactly the same because in make shared we have created the pointer for the first time. This is pointing to that location, and that means the data that we are pointing it with this will be exactly the same. So data will be exactly the same in both pointers. But what about the atomic counters? In the first one, the atomic counter is 1, but in the second one, the atomic counter is 1 as well. That means the first one that will be deallocated will remove the data entirely. And that means that the second one that will try to deallocate will do a double free. And that means a segmentation fault. And that's exactly what happened. So you must ask yourself, what shall we do about it? And there is a great tool in the Stardust library that was invented exactly for those reasons. Without further ado, let's write a new struct and let's test it. Now, let's see what will happen if we will run test on good. And voila, everything is fine and working. The next step will be to understand how did that happen. To understand what happens with good, we will have to be the debugger again. We will have to go line by line and understand what's going on in each one behind the scenes. In the first line, good create, nothing special happens. We are still creating a new shared pointer. This shared pointer creates a data area that points to that beef. And we have a management with atomic counter that equals 1. Then in line Y, when we are using X get shared, that is using shared from this, we are creating a new Y pointer with an atomic counter of 2 that points to the same area. That means that both pointers have the same management area, the atomic counter in both are 2, and the data area is exactly the same. That means when the pointers will be deallocated, the first one will just decrease the shared pointer, the atomic counter of the shared pointer, and the second one will decrease the atomic shared counter and then the allocate data itself. You must be wondering to yourself, how does enable shared from this achieves exactly what we need? It seems to be just a simple class that we inherit from. And the answer is simple as well. There is no black magic here. It is just constructor overloading for shared pointer. Shared pointer class checks if the type that is provided inherits from enable shared from this. And if it inherits from enable shared from this, it initializes the weak pointer inside it. More about weak pointers in the next episodes. And then each time, if the shared pointer was already created, the enable shared, or basically shared from this, will create a shared pointer from the weak pointer. Now, let's write an example of how the shared pointer may implement what it needs to achieve the overloading with types that are inheriting from enable shared from this. I wanted to show you the most modern code I could. So we will create a class that is templated on the type T. And we have two constructors for this class. The first constructor is using auto, ref, that means anything can get in, with params. And then we are just printing using a simple constructor. The second one is using a concept that is checking if T is derived from stud enable shared from this T. And if it is, then we will print that it's using an enable shared from this constructor. Let's see what will happen if we will actually use it. As you can see, we're printing using a simple constructor when we're using something that doesn't inherit from enable shared from this. And we're using enable shared from this constructor when we are actually using a type that is derived from enable shared from this. As simple as that. It's very important to understand that enable shared from this gives us a lot, but it's not perfect. To use enable shared from this, you have to create a pointer, a shared pointer, before using shared from this. That means if you will use it, since C++17, you will get a nice exception. But before that, if you're using older standards, it would be UB. And you know how horrible UB may get. So please be careful, use it correctly. As with everything with C++, you have to understand it to use it correctly, but when you do understand it, it will help you to write your code in a better, safer way. Hopefully after this video you understand how shared from this works, and I hope you will use it in the nearest future. Until the next episode, like and subscribe, and see you next time.